Hello everyone, we are going to now complete exercises 4C and 4D, which is all about cubic functions. The first thing we're going to look at is factorizing cubic functions. So if we have this particular rule, it can factorize down into a perfect cube and likewise into this form here. The difference, of course, that you can see are the signs. So these are both positives whilst these are negative, and that is what differentiates the positive and negative there. Next thing we have are the sum and the difference of two cubes. So if you have this particular form, we can factorize it into this form here. You can see that there's a positive over there, and then it becomes a negative here. This one is an error in the notes. So if you have a positive sign there, if you can just cross that out and turn that into a negative, so the difference of two cubes, if there's a negative in this part, then there will be a negative in this particular bracket, and then there will be positives in this sign here. So let's go ahead and apply all of that to what we can see here. So example 12, use an appropriate technique to factorize each of the following cubic expression. As you can see, there are 4 terms here, and it has a negative here, so it looks like it's going to take the form of a perfect cube, which has a negative. So the first thing I want to be able to see is whether the first term and the last term do work with our terms. So we've got a cubed and b cubed, so whether it's the positive or the negative. So if this were to be a cubed, then I can rewrite this as 3y all cubed, and then if this were to be b cubed, then I can write that as 1 all cubed. These middle terms are going to be the rest of the equation, so this would be 3a squared, this would be negative 3ab all squared. You can, of course, test it out to check that it really is the correct form. So if I were to substitute this in, say this is a and this is going to be b, this is what I should come out with. So negative 3 times a squared, so that's 3y all squared times b, which is 1. 3 squared is 9, y squared is y squared, so that'll be 9 times 3 is negative 27y squared, which is exactly the term that I have there. So in fact, this is correct. You can also test out the 9y and you'll see that it will work correctly there. So now that we know that 3y is term A and b is term 1, or either 1 is term b, we can substitute that directly into our a minus b all cubed, which is 3y minus 1. With part B, we can see that this is going to be the sum of two cubes, so that's x cubed plus 27. If I were to write this in terms of the form of a cubed plus b cubed, this will be x all cubed plus 3 all cubed. So now I can recognize that this is a and this is b, and I can factorize that down into the correct form. So if I were to go back, I can look at that. That'll be a plus b, so that's x plus 3, and then it's a squared minus ab, so that'll be 3x plus b squared, so that's 3 squared, which is 9. For part C, it looks like it's probably going to be the difference of two cubes, but what we can do firstly is take the 2 out to try and make our life a little bit easier. And then you'll recognize that both x and 8 are perfect cubes, which helps a lot. So that will be 2, x can be written as x all cubed, and then the 8 can be written as 2 all cubed. In this case, this is going to be a, this will be b, and then once again, we're going to substitute it into our formula. So that'll be 2, x minus 2, so a minus b, and then in the second part, all of them are positive. So that's a squared plus ab plus b squared. For part D, it looks like it's going to be our perfect cube formula because I've got 4 terms. Of course, we should always check to see that that is the case. So the first thing I can do is look at my first 2 terms, 8m cubed, that will be 2m all cubed. My last term can be rewritten as 5 all cubed. Now, if this formula is in fact correct, then this term should be 3a squared b. So let's substitute in our a and our b into this formula. So that'll be 3, 2m squared times b, so that'll be times 5. 2 squared is 4, 4 times 3 is 12, and then 12 times 5 is 60, so that'll be 60m squared, which in fact is correct. Of course, you can check this term as well, but it'll most likely be correct. So that means that I can factorize that down into the perfect cube. A is 2m, and b is 5, and because this sign is positive, so will the inside. Next, This one's a little bit more tricky. You can't use a specific formula in it, not yet anyway. What you need to do is rearrange this equation. So what I suggest is that you pause this video and give this one a shot and see if you can factorize it. Now what I can recognize is that I have an n squared and a 12n, and I also have a constant. It is a bit annoying that I have an m squared hanging out, but it looks like it's separate to all of those three other terms. So let's rearrange it so that it's in a little bit of a nicer form. The other thing that I can recognize is that these all have a common factor of -1, so I'm going to factorize that out and see if that helps me factorize in any way. Hopefully what you can recognize from this point is that this looks like the form a squared plus 2ab plus b squared. So this is just our perfect square. In this case, a would be n and b would be the square root of 36, which is just 6. To test out the middle term, 2 times a times b. So 2 times n is 2n times 6 is 12n. So it does work. So now I can factorize it down to look like this. That would be n plus 6 all squared. Of course, we're not done yet. We're now going to use dots. So I have two terms, and there is it's the difference between the square of those two terms. So that's m squared, or rather a squared, minus b squared. In this case, a is m, and b is n plus 6. And that factorizes down into a plus b, a minus b. So let's go ahead and write that in. So that'll be m plus n plus 6, and then m minus, now it's going to be minus all of the terms, so it's minus n minus 6. The next part, if you want, you can try out the perfect cube formula and you'll notice that it doesn't quite work. So this is going to require some different technique. Another technique that we can use when there are 4 terms of factorizing by grouping. So what I can do is take 2 terms at a time and take out the appropriate factor. So in this case, I can take out p squared. So that'll be p plus 2 left over. Here I can take out -4. That'll also have p plus 2 left over. You can notice that these are the same term. So I can take that out, and that'll leave over p squared minus 4. Once again, we're not done. You need to recognize that this is a squared minus b squared. Hopefully you can see the pattern and recognize how common it is. So in this case, our a is p and b is 2, sorry. So that'll be p minus 2 and p plus 2. I can write this a little bit neater because I can see that there are 2 terms of p plus 2. So I can just write that as p plus 2 all squared and p minus 2. So as you can see, all of these were quite easy to factorize because we have fancy rules that help us out. But what happens if we can't when we are trying to factorize a cubic? Well, there is another technique that is called long division, and that's what we're going to be heading into now. So we do want to learn a couple of theorems around this to help support us be able to complete this long division. The first is the factor theorem, and that idea is that if a particular expression is a factor of the cubic or quartic or whatever it is that you're trying to factorize, then if we were to substitute in this value of a, we would receive a remainder of 0. And that sort of makes sense with all values. For example, we know that 3 is a factor of 12. If I divide that, then I will get 4, and the remainder is 0. So that's the idea of the factor theorem. So let's go ahead and demonstrate this using an example. So in this case, our a term is going to be -1. So just so that it's clear how we get that, if x is minus a is equal to 0, then x would be equal to a. So in this case, we're going to try out the value of -1, and let's see if that gives us a remainder of 0, in which case x plus 1 as an expression would be the factor. So let's substitute that in, -1 all cubed 4 minus 1 squared plus -1 plus 6. -1 all cubed remains as -1. However, -1 squared makes it a positive, times -4 will be -4 minus 1 plus 6. So -1 minus 4 minus 1 is -6 plus 6 is 0. So in fact, when I substituted in -1, I received an answer of 0, which means the remainder of this expression is going to be 0. Now that's the first part. It says show that it's a factor, and then it says and hence find the other factors. Now there are a couple of different ways to do this. Firstly, I can try and substitute in different values into this equation to be able to find these other factors, these other values that give me 0. Or of course I can go ahead and long divide, which in this case I think would be the much easier way to do it. So I'm going to move this over to the side. And we're going to set up our long division. So we're going to write our cubic in here. And we know that x plus 1 is a factor. So this is going to be a reminder for you as to how to long divide from year 11. So first of all, we're going to check how many times does x go into x cubed, or the way that I like to just think about it is x cubed, x times what gives me x cubed. I'm going to need 2 more, so x squared. Then I will multiply, so x squared times x is x cubed, x squared times 1 is just x squared. And then I will subtract these 2 terms. So x cubed minus x cubed is 0 as expected, and negative 4x squared minus another x squared will be negative 5x squared. Finally, what I'm going to do is I'm going to bring down this particular term, and then we just do it all over again. So once again, x times what gives me negative 5x squared? That's going to be negative 5x. So negative 5x times x is negative 5x squared. Negative 5x times 1 will be negative 5x. I'm then going to subtract these. So negative 5x squared minus negative 5x squared will be 0 as expected. X minus minus, so plus, x plus 5x is 6x. And finally, I will bring down the last term. Do this one more time. X times what gives me 6x? That'll be 6. 6 times x is 6x. 6 times 1 is 6. Subtract these 2, and what you'll see is that you will get 0 as expected as our remainder. Now, of course, we're not finished yet, but I will need to make a little bit more space. Now that I've divided through, I have a quotient that is a quadratic, so it's much easier to factorize this myself. If it weren't a quadratic though, if I, for example, my original function was a quartic, this would be a cubic, so I would need to long divide again to get me to a point where the expression is a quadratic so I can easily factorize. All right, now what I have to do is factorize this, but I can easily use my normal technique, 2 numbers that multiply to give me 6, add to give me negative 5. That's going to be negative 3 and negative 2. So that'll be x minus 3 and x minus 2. So I do have 3 factors in this case. That's x plus 1, x minus 3, and x minus 2. Now for part B, it says factorize this function here, or this expression. That's exactly the same as we had before. I'm not really sure why they're 2 separate questions. I think here they wanted us to use the factor theorem to find these other factors, but in this case, the long division does the job. So in fact, it's the exact same answer. If we were to factorize it, it would be x plus 1, x minus 3, x minus 2, and just write a little note for yourself working out in previous part. Example 15. Very similar to the one before, except this time they haven't given us the factor, so we need to go ahead and find it. So what we're going to do is substitute different values of x until we get a remainder of 0, which indicates to us that that's a factor. So just so that you know which values we should be substituting in, it will always be factors of the last number. So in this case, what I should try out are the numbers plus and minus 1 and plus and minus 3. So those are the different values that can work. There is also the rational root theorem, which tells you about substituting in fractions, but that's something that we'll look at perhaps later on. So we can go ahead, we'll start with x is equal to 1, then we'll move to negative 1. I'm going to skip ahead, I'm going to go straight to x is equal to negative 1 and substitute that in. Negative 1 cubed is negative, so that'll be negative 2. Negative 1 squared is positive, so that'll stay as negative 3. Negative 8 times negative 1 is positive 8, and then minus 3. So negative 2 minus 3 is negative 5, minus another 3 is 8, so we'll have negative 8 plus 8, which will be 0. So we have gone ahead and found our first factor, which is going to be x plus 1. Remember, the sign changes. Now that I've found that, what I'm going to do is long divide as we had previously. So I'm going to write my expression. So that's 2x cubed minus 3x squared minus 8x minus 3. And our factor, x plus 1, and we're going to go ahead and divide now. So x goes into 2x cubed, 2x squared times, multiply that out. So 2x squared times x is 2x cubed, 2x squared times 1 is 2x squared. Now we're going to subtract 2x cubed minus 2x cubed is 0 as expected. Negative 3x squared minus 2x squared is negative 5x squared. Then what I can do from there is I can drop the next factor. So that's negative 8x. And then we do it again. X times what gives me negative 5x squared? That'll be negative 5x. Negative 5x times x is negative 5x squared. Negative 5x times 1 is negative 5x. Subtract negative 5x squared minus minus, so plus, 5x squared is 0. Negative 8x minus minus, again plus, so negative 8x plus 5x is going to be negative 3x. And then what we're going to do is drop down the last term, so that'll be negative 3. X goes into negative 3x, negative 3 times. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Subtract all of that. Negative 3x minus minus 3x is 0, and negative 3 minus minus, so plus, negative 3 plus 3 is 0, as expected. We now have our factor, and we also have our quotient, and we can now factorize from there using our normal quadratic rules. So as we can see, we've got a value at the front, so we do need to do our A times C technique. So we want two numbers that will multiply to give us negative 6 and add to give us negative 5. Those two numbers will be negative 6 and 1. So I'm going to go ahead and split the middle term. So it'll be 2x squared minus 6x plus x minus 3. I'm now going to factorize by grouping. So here I can take out 2x, x minus 3 is left over, and then x minus 3 is left over in this term. X minus 3 is the common factor, so I'll take that out, and what's left over is 2x plus 1. And there you have a fully factorized cubic. The next theorem we're going to look at is the remainder theorem. It's very similar to the factor theorem, but what it tells us is that when we substitute in a value, whatever we get out is the remainder. So with factor theorem, it's the same. It's just that specifically if that number is 0, it means that the expression is a factor. In this case, it just tells us that if a function, a polynomial, is divided by ax plus b, then the remainder, or the value that we get out, is the remainder. Remember, once again, it's all about changing the sign. So it's as if I'm solving for x. First thing I'm going to do is take the b over, then divide by a. So that's the value I need to substitute in, and that's what gives me the expression ax plus b. So example 16, find the remainder when. So I don't need to do my long division to be able to find this. I can just use my remainder theorem. So the first thing is the value I'm going to substitute in is 1. So when I substitute 1, so p of 1, 1 cubed is 1, 1 squared is 1, minus 3 plus 1. 1 minus 1 is 0, minus 3 is negative 3, plus 1 is negative 2. So that indicates to me that that's going to be the remainder there. Once again, now we have a more difficult expression, so 2x plus 1. In this case, again, make it equal to 0. I'll take the 1 over and then divide by 2. So the value that I'm going to substitute in is negative a half. So it's the same thing, it's just that using fractions is going to be not as nice this time. Just move that over. Okay, so let's expand all of this. Negative a half cubed is negative 1 on 8. Negative a half squared is positive a quarter times 3, so that'll be 3 quarters. Negative and negative makes positive, so that'll be 5 on 2 plus 7. And just to make my life easier, I'm going to make all of these, or put all of these onto a denominator of 8, because that's our largest common factor. So that'll be times 2 times 4, and then if that's on 1, I will multiply both by 8. So in terms of fractions, I will have 1/8 plus 6/8 plus 20 over 8 plus 56 on 8, and when you add that all together, you'll get 81 on 8. Next example, example 17. The function f of x is equal to 2x cubed plus ax squared plus bx plus 3. It has a factor of x plus 3. When f of x is divided by x minus 2, the remainder is 15. Calculate the values of a and b. So we have two unknowns. That means we need 2 bits of information. Essentially, we'll be creating 2 simultaneous equations that's going to help us find this. So let's interpret the information that they've given us. The first thing it's told us is that it has a factor of x plus 3. What we know, therefore, is that when we substitute in negative 3, the remainder is going to be 0. So that means f of negative 3 is going to equal 0. Likewise, it tells us when the function is divided by x minus 2, the remainder is 15. So very similarly, when I substitute in x is equal to 2, so that'll be f of 2, my value will be 15. I now essentially have 2 points that I can substitute into this function and then solve for both a and b. So I'm just going to call this 1 and this 2, so you know where I've put them in. So let's go ahead and substitute this. This is x and that will be y. So 0 equals 2 times negative 3 cubed plus a times negative 3 squared plus b times negative 3 plus 3. When I work out all of these values, I will get negative 54 plus 9a plus 3b plus 3. I'm just going to make this look a little bit nicer. So first of all, negative 54 plus 3 is negative 51. And then when I take that over to the other side, I'm going to get positive 51 is equal to 9a plus 3b. And to simplify it as much as I can, I'm going to divide everything by 3. So I'll get 17 equals 3a plus b, and that'll be my first equation. And then I'm going to do something, oh my God. I'm then going to do something very similar for part 2. So in this case, this is x and this is y. I'll substitute those both in. So that'll be 15 is equal to 2 times 2 cubed plus 2 times 2 squared minus b times 2 plus 3. When we work this all out, we're going to get 16 plus 4a minus 2b plus 3. Now 16 plus 3 is 19. When I take that over to the other side, that'll be 15 minus 19, which is negative 4. That's 4a minus 2b. And then, as you can see, I could simplify this by dividing everything by 2. So when I divide everything by 2, I will get negative 2 is equal to 2a minus b, and that will be my second equation. Finally, what I'm going to do is use simultaneous equations. So I'll just write out both of my equations that I've got. So that'll be 17 equals 3a plus b. And equation 2 is negative 2 equals 2a minus b. In order to use elimination, because I've got the same term here, but one of them is negative, I'm going to add both of these functions. So I'm going to do equation 1 plus equation 2. 17 plus minus 2 will be 15. 3a plus 2a will be 5a, and then b plus negative b will cancel out. It'll be 0. When I divide both sides by 5, I'll get a is equal to 3. Then what I can do is substitute that back into either one of the rules. I'm just going to substitute it into 2 because it has smaller numbers. So I'll say sub a into 2. So it'll be negative 2 is equal to 2 times 3 minus b. 2 times 3 is 6 is equal to negative 2. I'm going to take the b over to this side to make it positive, and the 2 over to this side, which also makes it positive. So I'll get b is equal to 8. And those are my two values. Now that we have the equation, what it wants us to do is to find the other two factors of f. So the first thing I'm going to do is write out the function that I have with the new values that I know of x, of a and b. And I already know that one of the factors, as it told me in the question, is x plus 3. So I don't have to go through the process of finding out that value, but I will need to just long divide. So x goes into 2x cubed, 2x squared times 2x x is 2x cubed, 2x squared times 3 is 6x squared. I will then subtract. So 2x cubed minus 2x cubed is 0. 3x squared minus 6x squared is going to be negative 3x. Oh my God. Is going to be negative 3x squared. I'm then going to take down the next term. X goes into negative 3x squared, negative 3x times. Negative 3x times x is negative 3x squared. Negative 3x times 3 is negative 9x. I'm then going to subtract. So this will be 0. Negative 8x minus 9x will be positive 1x. I'm then going to take the 3 down. X goes into x one time. 1 times x is x. 1 times 3 is 3. When I subtract that, I will get 0. So now I have a factor. I have my divisor. Again, there's a value out the front, so I have to use the a times c technique. So a times 3, which will be 2 times 1, means I need two numbers that multiply to give me 2, add to give me the middle term, which is negative 3. That'll be negative 2 and negative 1. So x plus 3 split the middle term, 2x squared minus 2x minus another x plus 1. Factorize by groupings. I'm going to take 2x out, so that'll be x minus 1 left over. I'll then take the negative out, that'll leave x minus 1 again left over. These two are a common term, so that's x plus 3, x minus 1, and 2x minus 1 as our leftover. So when it says find the other two factors are going to be x minus 1 and 2x minus 1. And that is the end of these exercises. So now you can complete exercise 4C and 4D.